Howdy, we're Team Elevate, elevating the safety, environment, and connectivity of Nolanville. Our team is comprised of 4 different majors including visualization, computer science, urban planning, and landscape architecture.
Our project includes 3 parts. Part 1 is our introduction, Part 2 is our technological proposal, Part 3 are the design proposals. Our mission is to identify, record, and evaluate flood-prone areas and enhance them. We plan to stabilize slopes with vegetations, mark pollinator gardens for fragile habitats, while also creating new active and educational spaces for residents. By developing a digital application, we want to guide and help residents avoid flood zones and train traffic to enhance their daily life.
Our primary goal is to elevate the safety, environment, and connectivity within the city of Nolanville. Our master plan combines the work from all 4 majors and includes safety features such as erosion control and a flood prediction and warning system, environmental features like tree canopy coverage and pollinator gardens, and connectivity features including mixed-use spaces and a citywide communication app.
So for our NOVE layout, the picture you see there is the general layout of our incident reporting app. Throughout our app, different incidents can be reported such as flooding, train blockage, fires, etc. Clicking on the report button on the homepage will lead us to a map where markers can be placed at the location of the incident. The flood incident reporting can be used as potential data for our machine learning proportion. Currently, we're using Flutter to develop this app in order to make it easier to deploy on both Apple and Android devices.
So this is our general map layout. We're using the Google Maps API in order to report locations. So once the user hits the report button, the user can report a fire, report a train stoppage, etc. And once the user reports it, it would appear on the alerts page, as you see in the picture on the right. And residents can be notified whenever a report occurs. And we intend to have some sort of administration process for the reports so that all the reports are valid.
For the settings, on February 15th, we actually went to Nolanville ourselves to interview the residents there in obtaining additional information that could be instrumental in developing our app and maximizing our utility. We've learned that there are 4 main exits that are blocked by the trains. These exits can be blocked for a few minutes because the train is just passing by, which is a minute nuisance for most, or up to 45 minutes because the train has stopped completely to allow other trains to pass. Our goal is to accurately characterize trains that will completely stop and block intersections for a significant amount of time. In this situation, we can notify the resident in accordance with their desired time interval to receive notifications, and give them the option to reroute themselves to drive around the blocked intersections.
For the machine learning segment of this project, we decided to create a flood classification system. We used a simple data set about the climate conditions in Austin, representing temperature, dew point, humidity, sea level pressure, visibility, wind speed, wind gust, and precipitation sum. We created 5 different classes, 1 representing no flooding at all, and 5 representing a flood depth of about ankle deep. We decided to create a neural network based on this data, and we were able to achieve a model accuracy of 95.5%. As you can see, our loss decreases as we train the data on more epochs.
Now, unfortunately, due to coronavirus, we were unable to revisit Nolanville and collect certain flood data that we needed for testing. So instead of that, we decided to look at other alternatives in order to test our model. Now, Project Safe Waters is an open source repository, and it allows us to use their data and their model to predict flood levels and improve their accuracies. And we can also utilize these on custom data. The best thing about this is that rather than finding real-time data, we can actually use a Unity model of a city. And what they did was they used a Unity model, which is basically a game development software, and they built a city. And then they made it rain in that city and caused a lot of areas to flood. Thus, you end up with a simulation where flooding takes place at different locations. These floods were then sent through an IBM Watson interface and were annotated. That is, labels were assigned to every single image within this simulation. After we obtained the annotation and the labels, pre-trained weights were obtained and the model was then tested for 9,900 different images. These images were basically the images from the previous simulation that we discussed in the last slide. The flooding was then classified as dangerously deep, feet don't touch deep, knee deep, and waist deep. And what we observed was that 642 of those images were dangerously deep, 3,663 were feet don't touch deep, 2,902 were knee deep, and 2,694 were waist deep. The next phase of this process would actually be to build a few streets or neighborhoods that mimic Nolanville, as in using the Unity model and making a simulation of Nolanville itself, then testing those images with the model. The third method that we used to tackle floods at Nolanville was a real-time flood detection model. In order to do this, we used the YOLO neural network, which is a real-time object detection neural network. The way YOLO works is that we first use a bunch of images, or rather flooding images from the internet, and trained our model based on those. Then we used some more flooding images as our testing set, and we used those to see if YOLO could recognize the presence of a flood. If YOLO did detect a flood, it drew a bounding box around the region where a flood was observed, as you can see in the 3 images below. These results proved to be really useful, as we could use this model along with surveillance cameras at Nolanville, where we could place the camera near a street that floods a lot, and the moment the model notices a lot of floods through the camera, it could alert the authorities and they could take any necessary action.
The flowchart in the top right corner shows the user's options throughout interacting with the app. It was designed with collaboration between both visualization and computer science students. The user has the option to make a report, view past reports, view reports on a map, and more. The color scheme in the bottom right corner is the product of 5 different user surveys. The surveys are designed to help achieve the most effective colors. There were a total of 15 different color scheme options, each one having a different take on the emotional colors associated with the community of Nolanville. This includes the 2 light blue towns featured in the town's logo. The layout of the start screen includes the app logo, a geomarker with an E on it, along with 3 user options. Of these 3, the most important is the quick report option, which allows for users without an account to make reports on time-sensitive things, like severe flooding. The home page was designed with the buttons placed in a comfortable area for thumbs, since users will be quickly trying to reach the pages that they need. The 4 main areas of the app are Report, which allows users to make reports, Report History, which allows the user to see all the reports that they have made in the past, Active Alerts, where the map that with all the ongoing alerts are, and Alert History, where users can see older alerts that are no longer important. The hamburger menu at the top right of the screen opens up to the settings page, where users can customize their notifications and log out if they want to. The settings page allows users to customize the app the way that they would like. They can change their name and information, as well as the amount of notifications that they receive from the app. The reports page allows users to choose the different types of reports, or to choose other and give a description. An example of why this option is necessary is if a deer or other large animal is attempting to cross a road, a user could make a report about it and help other drivers to avoid the animal. The past reports page shows all of the reports a user has ever created, with icons for if other users have added other types of reports in the same spot within a set time, such as a flooding from the 10th Street drainage pond causing a traffic jam to be reported 10 minutes later. The Active Alerts page gives the user the ability to see what is happening throughout the town. The information given about the alerts includes the type, location, time, a short description about the report, and the name of the person who made the report. To keep the app cohesive throughout every page, the 2 different alert pages and the past reports page are designed to appear very similar, with minor details being changed in between. The past alerts page shows the alerts made in the past week. The information given is similar to that of active alerts, except these are also given a date to the report. So they include the address, the type of report, the time, the date, the name of the person who made it, and the short description.
Nolanville is comprised primarily of residences. A large amount of those living in southern Nolanville lie within the floodplain. The proposed park locations all lie within the floodplain as well. On the right is a map indicating the 5-minute walking and biking distances from the proposed park locations.
As a team of urban planners, we looked at the preferred future land use plan from the Nolanville Comprehensive Plan and came up with the land uses that'll be the best fit for each section. Here shows our conceptual diagram of the area. This is a more detailed version of our conceptual plan showing how it could potentially look. Our overall goal is to improve the urban connectivity throughout Nolanville, making it easy for residents and visitors to move with ease to the next place and to promote community engagement through the implementation of the green space and community garden, as well as the goal to promote walkability throughout the area. The streetscape promotes safety with tree canopy coverage and helps the environment with the incorporation of a 6-foot planting buffer. The streetscape provides connectivity with the use of a 12-foot pathway, which is divided by a painted striping to indicate the size for bicyclers and for pedestrians. The plant selection is chosen locally and features easy maintenance. Pollinator gardens help to promote bee and butterfly populations, which benefit the environment. The slope stabilization plants were chosen to have deep rooting, which will improve flooding conditions and help to decrease erosion.
Jamboree Park's most important safety feature is the gabion reinforced drainway. Environmental benefits from Jamboree Park come from collecting rainwater and using it as irrigation. The final goal of Jamboree Park is to activate use of the northwest side of town. This is the gabion reinforced drainway that can also be used to connect residents with the water. Along its path will be flood sensors and pollution sensors. Here is a look at the rainwater collector. As a nod to the city's relationship to the train, the secondary trail will be made with railroad ties.
This community park is located on the north side of the city. It is right in front of the current community center. The purpose of this park is to mitigate water and prevent flooding in the area. The park contains a bioswale that will serve as the main water mitigation system. The bioswale will contain local plants that help with the erosion and water pollution. The park itself is designed to flood during long rain periods, providing the community with less hazards that come from flooded streets and homes. When the park is dry, it is meant to be used as a normal recreational space. The park is well shaded and has a defined path for exploration. The park is ADA and it is accessible to everyone. The bioswale component is part of the water mitigation and pollution prevention system. Water is led to the water treatment and drainage but can overflow into the park if needed. There is a plan of adding water testing sensors that can help people understand how the bioswale works. The sensors can indicate how clean or dirty the water is and see that the swale is doing its job. The park then is part of the whole initiative to create safe, walkable spaces for the community. Here's a perspective of the bioswale showing what it might look like when the water levels are high just before it begins to overflow into the park. Features to look at include the safety wall providing protection and a high point view, the vast amounts of shade, and of course the bioswale.
Pecan Trail promotes safety for users with a half a mile of lighted walking and biking trails. The environmental aspects are seen through the use of erosion control methods, including plant selection and gabion slope enforcements. The site supports connectivity with kiosk and wayfinding signage to help users navigate the space. The east side of the park has safety features which include gabion reinforcements. The environment is improved with the use of a pollinator garden and connectivity is promoted through multi-use spaces. The Learning Center features a pavilion, slope reinforcement plants, wayfinding signage, and a local planting selection. The west side of the park promotes safety through flood sensors along the river to alert app users of hazards for the area. Natural materials are used to help the environment by being more durable. Connectivity is enhanced through the use of a bus drop-off location to promote group activities and facilitate school buses. Located at the trailhead of the park is a bus stop which features a covered bus station, a drop-off lane for easy accessibility, wayfinding signage, and different seating options.
Implementation of these projects has been divided into 3 phases. Phase 1 is comprised of constructing the 3 parks and a bike and walking trail to connect them. This also marks the beginning of constructing the mixed-use features. Phase 2 connects the sidewalks and bike lanes to all the schools in Nolanville, including the new elementary and middle school in the southern portion of town. There's also a second pedestrian crossing along the highway. Phase 3 consists of the completion of the mixed-use space, citywide trail, and a third pedestrian crossing across the highway. In summary, the safety, environment, and connectivity in Nolanville will be elevated with the implementation of flood sensors, protected pedestrian and bike paths, gabion reinforced slopes, pollinator gardens, and finally a citywide app and trail system. Thank you.